Hello students, welcome back to AriserTalent. I am your maths teacher, Arpita Sharma. Students, what we are studying? The very first chapter of our class, this is number system, okay. So, starting from writing the name of our chapter, which is about numbers, number system, right, okay. So, we are going to study about this in the very first lecture. We have discovered that this number system is divided in different branches. We have studied or we have just brief about the real and imaginary number, then rational and irrational number, then fraction number, integers, natural number set and whole number set, and positive, negative integers, non-positive integers, non-negative integers, and all that thing we have covered. Right now, it's a time to just see that what we have understood in the previous lecture, actually we have understood it or not, okay. So, what I am going to do is just gonna ask some questions to you. First is, what is rational and irrational numbers, okay. So, here it is students, rational and irrational numbers. Okay. So, here it is rational and irrational numbers. So, students, we have talked about these rational numbers. Rational numbers. What are rational numbers? And then what are irrational numbers? I have told you that students, these rational numbers are the one that can be written in the form of, the first thing is, that can be written in the form of P by Q, where Q cannot be 0 and P and Q are integers. This was the very first thing, and the second thing was P and Q, and this is small p, right. So, okay, small p will write. So, P and Q are co-primes. Understood the meaning of co-primes? That means these numbers will be not having any common factor other than 1, okay. So, these are the two conditions. Now, any number which is not rational or which cannot be written as P by Q format is what? Is what? Irrational number for sure, okay. Any number that cannot be any real number, okay, any real number that cannot be represented as rational number is just the opposite, right. That means is irrational number. Isn't it so simple to understood that what is rational number and what is irrational number, okay. So, this is the basic, and we are going to deal with some rational numbers in this particular lecture, okay. So, noted, okay. So, this is about rational and irrational number. Now, moving to our next slide, which is sets in which 0 lies. Basically, this is a question, and keeping in view that we have talked about this stuff, so better you answer this, okay. You should know this, you must know this, that what are the sets in which 0 lies. So, if I am talking about this first question, let us suppose this is the first number and this is the second number question, okay. So, for the first one, 0 lies in sets. So, I am having natural number set. Natural number set will work like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So, in natural number we are having no 0, whole number set. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, the first will be whole number set. Whole number set, or we can write W, right. So, in that set we will be having a 0. Second thing, integers are from minus n to minus 3, minus 2, minus 1, then 0, then 1, 2, 3 up till n. That means it is having 0 also here. So, we are having in integers. Okay, that is 0, 1, 2, 3 till n, and that was Z you can say, or I you can say, and that will be minus n to something like minus 2, minus 1, 0, 1, 2 till n. Okay. So, this was like that. Then the third one will be integers have done. Now, positive integers, no, 0 is not included. Negative integers, 0 is not included. There comes non-negative integers, that will be 0. Okay. Non-negative, that means all positive, 0, 1, 2, 3, 4. That is a complete whole number set. Okay. Non-negative integer set is whole number set. Then the fourth one, non-positive integers. Non-positive integers, that means from minus n to minus 3, minus 2, minus 1, 0. So, that will be 0, 1, minus 1, minus 2, minus 3, or in this way minus n 2, minus 3, minus 2, minus 1 and 0. So, these are the sets including 0. Then we are having a discussion also that rational number. Is 0 is a rational number or not? We are saying that 0 can be written as 0 and 1. So, yes, in rational number set 0 is also included. So, these are the sets in which 0 lies. Okay. So, better you note that, then we will be just going to our next question. So, the next question is non-positive and non-negative integers. Okay, I just rubbed that, but in that part we have covered that thing also. Non-positive and non-negative integers we have covered in that particular portion also. If I talk about this non-positive, and I will be going with this non-negative. So, non-positive is 0, minus 1, minus 2, minus 3 till minus n, and for non-negative that is 0, 1, 2, 3 till n. So, note this, students, note this. Okay. Okay. So, done with these two questions. Now what? What is next? So, for the next one, okay, we will be having this true and false session. You have to make sure that whatever you are saying, true or false, that should be with a valid reason, because I have to ask this, not random things that ma'am this is true, oh, this is false, and this is true. No. Every integer, first one is every integer is a rational number. Every integer is a rational number. So, first our integer set, we are solving with the number 1. Okay. So, if I talk about integer, then this z includes from minus n to minus 2, minus 1, 0, 1, 2 and so on, and we know the story, right. So, this z is something like this. Now, minus n can be written as minus n by 1, Okay, now minus 2 can be written as minus 2 by 1, then 0 can be written as 0 by 1. That means what? Any of the integer can be written as p by q form, and here in the denominator we are not having 0. So, okay, and we are not having any common factor other than 1 in p and q. So, fine, they can be written as p by q. If they can be written as p by q, that means what? These are all rational numbers. So, every integer is a rational number. Every integer here is a rational number. Okay. So, this is true. Okay. So, this is true. Now, the second one, every rational number is an integer. Every rational number. Every rational number is talking about. Okay. So, 1 is an integer, right? It's an integer. So, 1 by 1. Okay. Minus 1 by 1. Okay, then we will be talking by 0 by 1. Okay, then we will be talking about 6 by 2. That's 3 of course, but this is also a rational number. So, now if I talk about this 3 by 2, 3 by 2 is a rational number for sure. This is a rational number. Okay, but it's saying that every rational number is an integer. So, it's an integer? No. It's a rational number, but it is not an integer. Okay, so it is not integer, but it's rational number. So with this thing that every rational number is an integer, this comes to be very, very false, right? This is false for sure. Now every natural number is a whole number. Every natural number is a whole number. Okay, so when I talk about natural number and set, that is our 1, 2, 3, 0 is not included here. Okay, so not 5, there will be n. Okay, so it's saying that every natural number, so these are all possible natural number is a whole number. 1 is whole number, right? 2 is whole number, okay. 3, right? 4, yes, and yes, it is also a whole number. Okay, so what we concluded with every every natural number is a whole number is true. These are all natural number. Okay, these are all natural number. And if I talk about the whole number, this is 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 whole number. That means this is very, very true statement to be said that every natural number is a whole number. Okay. Okay, so talking about this fourth one, every integer is a whole number. Now, how will you see this? That now you know the pattern, na? That whatever whatever stuff we are talking about. Likewise, we were talking about integer here. We put that integer thing here and just checked that that whether the integers, all integers are rational number or not. Okay, so in this case similarly what we will do, we will be putting an integer set and we will check that whether all the integers are whole number or not. That's so simple. Okay, so what we are going to do is for the fourth number 1, I will be having this integer that will be minus n minus minus 3, minus 2, minus 1, 0, 1, 2 till n. Okay, so if I'll talk like this, that whether this is right or wrong, so these are all integers. Now I have to check whether these integers are whole number or not. Now this is whole number, this is whole number, this is whole number, this is also whole number, but this is not a whole number. This is not a whole number, this is not a whole number. That means if you talk about every integer, so no, every integer is not a whole number. But if I talk like this, that whether the every positive integer, now mark my words, every positive integer is a whole number. Yes, it is, because if I talk about positive ones, that will be this side only, like from 1 to till n. And now every positive integer for sure is a whole number, but not every integer. Okay, when I remove that positive word from there, that will be a false one. So that the fourth one will be a false one. Now the fifth one, every rational number is a whole number. Every rational number is a whole number. We have talked about the every rational number is an integer. Okay, now it's time for the every rational number to be whole number or not. So okay, what we'll do? What are rational numbers? Rational numbers are simply in the form of P and Q, P by Q format. So if I talk about 1 by 1, this is rational number, right? And this is whole number, right? Again, I have told you like that in that way. 3 by 2, it is rational number, right? It is whole number? No. 3 by 2 is nothing like a whole number, but 3 by 2 is a rational number. So every rational number cannot be whole number. Okay. So every rational number is a whole number is a lie. So false. Now the next one is every whole number is a natural number. Every whole number is a natural number. So for that we will be going here. Okay. So whole number is what? Whole number is set here. Whole number set, the sixth one. So whole number set is W equals to 0, 1, 2, 3, 4 till n. Okay. So every whole number is a natural number. N is natural number. Yes, n is a natural number. Okay. 4 is natural number, 3 is natural number, 2 is natural number, 1 is natural number, 0 is natural number. 0 is not a natural number. 0 is not a natural number at all. That means every whole number is a natural number. This statement is false. Okay. Every whole number is a natural number, it's a false. Okay. Some whole number can be natural numbers other than 0. All the whole numbers are natural number, but 0 is included in the whole number category. So this is false, that every whole number is a natural number. Every natural number is whole number is true. Okay. Every natural number is a whole number is true, but every whole number is a natural number is false. Now these statement may look like difficult to remember like this, that whether it's true, whether it's false, but when you will be doing this this complete set thing, that when you will be having that sets and will look at these particular statements, then you can easily find out that whether these are true or false. Okay. So done with that, just copy that and then we will move forward. Okay. Copied, right. So now you can tell any of these statements to be true or to be false, right? Okay. So in the next question is about, okay, insert 5 rational numbers between 1 and 2. Now students, in our previous classes, like you may recall that we are having some number r, some number r and some number s, and if I have to insert a number between these two, then what will I have to do? It's just simply I have to add them and then divide them by 2, right. So there will be a number that will be r plus s by 2, and that will be for sure in between r and s. So we can have a number between r and s, that is r plus s by 2. Is it clear to you guys? Because mean of them, average of two number will lie only between the two. Okay. So if this is number line and here lies r and here lies s, so the average of these will be always lying between these. if this is a number line and I am having some number r and some number s here, so this is very simple. Okay, now how it's so simple? I have to insert 5 rational numbers between 1 2. Okay, so r equals to, what should I change the color here? Okay, so r equals to 1, s equals to 2. So the first value is equals to simply 1 plus 2 by 2 by the formula r plus s by 2. Okay, is that so? Now this is simply 3 by 2. Now I am having this 1 and 3 by 2 and 2. Okay, so now I have to insert a number between these two and these two. That will work. Okay, so that will be, for these two, that will be 1 plus 3 by 2 by 2, isn't it? And that will be 2 plus 3 by 2 by 2. Why? Because the average of this will give a number between these two, and average of this number this will give the number between these two. So basically I am having 1, 2 and 3 numbers between these two. So should we solve it further? That will be, this is 2, taking LCM 2 ones are 2, 2 plus 3 is 5, so 5, and this is 2. Okay, 2 multiplied by 2 will give you 4, so this is 5 by 4. Here, come here, 2 to the 4, 4 plus 3 is 7, so that will be 7 by 4. So now that will become 1, 5 by 4, then 3 by 2, okay, and then this value 7 by 4 and this 2. Now we are to fill the 5 rational numbers here. So this is 1, this is 2, this 3, this 4, this 5. 5 between them, 2 missing. Okay, what can be done? We can have either 1 from these two and 1 from these two, or what we can have in between them and in between them, that's all our wish. So I'll be taking this one. So 1 plus 5 by 4 divided by 2, then here for the 7 by 2 and 2, in between them we will be having this 2, 7 by 4 plus 2, and that will give us 7 plus 4 to the 8 by 4 by 2, that will give you 15 by 8. So there is this number. Now what we were seeking was, the first value was 1, and then we have to insert 5 numbers, 1, 2, 3, or can we make boxes here? Okay, so there were 1, 2, 3, 4 and 5 numbers, and then there was a 2. Okay, so how will be inserting numbers in that? The middle value, this is 1, the middle value found out to be 3 by 2. Okay, the average of first these two will be 3 by 2, so this value will be 3 by 2. Okay, 3 by 2. After solving this, we covered this value 1 and 3 by 2, and here we got 5 by 4. Now after 5 by 4, we have inserted a value 9 by 4 between 1 and 5 by 4. So after 1 we will be having 9 by 4. Okay, and here it will be that is 8 here. Okay, after solving this you will be getting this 9 by 8. Okay, so you will be getting this 9 by 8 here, and then this 5 by 4. Okay, 3 by 2 as it is. Then after 3 by 2 you have inserted after 3 by 2 7 by 4. Okay, so this 7 by 4, 7 by 4, or right, you'll be having the 7 by 4 here. Okay, 7 by 4, and after 7 by 4 you will be having this 15 by 8 here, 15 by 8 here. So, these are the values 9 by 8, 5 by 4, 3 by 2, 7 by 4 and 15 by 8. These are the values. Now, these value can be vary. How? If you pick values this and this, and after finding these values you decide to pick a value between these two and between these two. So, there will this value will shift to this one, this value will be shifting to this one, and here we will be having average of these two values, like here we will be having average of these two values. So, the values can be something else, but these all values, either way your answer is correct. Okay, we are having some values in this case where we find out to have the mean of these two, but like these two, okay, but if you decide to take mean of these two, there will be a value in between them. So, either way it is okay, right. So, note this, noted. Okay, so this is our question. And irrational number. Irrational number is something that cannot be a rational number. So, if I write this rational number and I will put this IR here, that will become irrational number. That means which is not rational is irrational, right. So, we will talk about this irrational number, this how this is going to be, but before studying that thing, I want you to remember that when we are talking about rational numbers, rational numbers are two which are fractional and integers. Okay. Fractional and integers. Integers, you know, 1, 2, 3, 4, 5, 6, 0 and 1, minus 1, minus 2, minus 3, minus 4, and fractional number you learn, you know, like P by Q format. Now, P by Q format and which even may not include the integers here. Okay, these are fraction. Total thing is we are having some rational numbers, and rational numbers may be categorized as terminating, non-terminating, but repeating. If I talk about the decimals to be counted, if decimal, if I write a number in decimal format and it's terminating, first it's terminating, then there is a one situation, okay, and if it's non-terminating but repeating, then there is another situation, and these will lie only in rational number. But on the contrary, we are having our irrational numbers having this non-repeating and non-terminating numbers. This is a remaining category, and this is what we call as irrational number. Now, give it a thought to the value of pi and the value of root 2 and the value of root 3. Give it a thought, and we will talk about these numbers, the root 2, the pi and these root 3 numbers in our next session. Till then, enjoy your life and take care of yourself. Bye bye.